If you know them, don't tell them that I think that they're going to win. I don't want too much pressure or whatever on them. I'm pretty sure. I mean, we usually win, but like this year, I think we're especially going to win. 211.
Isn't the event that Math Club here puts on for the kids?
No, that's for high school.
It's just for high school?
Yeah. Math counts is it's just for middle schoolers. Yeah, anybody ever do it? Anybody an athlete? Were you a mathlete? I was an athlete. I was on the math counts team. Oh, it was, well, you might not have had it, but it existed. All right, let's try this one. What is the equivalent capacitance of this circuit? Here, C, C, and C, they're just all, there are no numbers, so you just have to find the equivalent capacitance of that circuit. Remember in our rules, capacitors in series and parallel, capacitors in series, the equivalent is that 1 over C plus 1 over C. For series, it's, for series, it's 1 over C plus 1 over C. For parallel, you just add them up. I'm going to write those down. For series, the equivalent is 1 over C plus 1 over C. For parallel, it's C plus C. Whatever your capacitors are. Okay. A lot of you do have the right answer, but we're sort of all over the board too. So feel free to ask your neighbor when you think you have an answer. Just tell them, shout it out to them. Yes, Stephen? Yeah, what's your question? That's right. Remember that you want to start with your smallest as in series or in parallels. Notice that these two capacitors, because there's no junctions between them, these are in series. So you have to find this first, and then you combine it with this, which is in parallel. All right, we're still a little bit all over the board. I'm going to stop though at 245. I'll show you. Do it. 245. Once y'all get an answer, you like to stick to it, don't you? Is that right? All right. I'll show you. The answer is A. All right. Yes. All right, I do this one first. So that's going to be 1 over C plus 1 over C. That's 1 over 2 over C, which is 3 halves C. Or I'm sorry, no. C over 2, excuse me. C over 2. And then I'm combining this capacitor with C over 2, so I say C plus C over 2, which is 3 halves C. All right, so the answer is A.
Okay.
Yeah, Ainsley?
Why would you choose the parallel one?
Because it's not purely parallel. Because I mean, what would I do? I would do, this is what a lot of students do. They do these two, right?
Yeah.
But look, you got this thing in here.
Okay.
And this thing is in series. Now, a better way to draw this that might help you to understand it a little better is to draw it where that's my first capacitor, this one, and then like that. And then you can see it more clearly that those two on the right are in series. Okay? Don't worry, you're in good company if you get that wrong, but you need to get it right for the test, okay? All right, how does the voltage across the first capacitor compare with the voltage across the second capacitor? The voltage across here, V1, compare with the voltage across here, V2. Okay. Let's do about 15 more seconds. Y'all are pretty evenly split on your answers. I'm going to stop at 120, 120. All right, so you're evenly split between A and B. Somebody put C. So let's think about it. I'm just going to give you a little hint, and then I'll let you try again. Now, if I have my circuit, this is C1 and this is C2 up here. I have 10 volts here. Because these are in parallel, I will have 10 volts across this capacitor. I will also have 10 volts across these two capacitors. So now let's try that answer again. How is C1 and how are V1 and V2 going to compare? Will V1 equal V2? Will V1 be greater than V2? Or will it be less than? It is either A or B. Is it equal or greater than? Awesome. All right, I'm going to stop at 25. B is right. V1 is greater than V2. Look, I have 10 volts here. I have 5 volts here, 5 volts here. 5 plus 5 has to equal 10. All right? Good job. Oh, what is the current in this circuit, by the way? If I have this circuit and it's all charged up, what is the current in that circuit? I mentioned this last time, but what's that? In the whole circuit. What is the No, the little follow-up. What is the current in this circuit? They're all charged up. It's very zero. So once they're all charged up, the circuit just stops doing anything. Right? The battery sends out charges to these capacitors, boom, 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 and then once they get charged up, there's no current at all. We'll see that in chapter 4. We'll get into RC circuits. So we're just talking about these circuits as if they're now fully charged. All right, how does the charge Q1 on the first capacitor compare to the charge Q2 on the second capacitor? Q1 to Q2, how do those compare? This is the same circuit as the previous question. Think about how the voltages compare, and then ask yourself, how should the charges compare? Look up. V1, bigger, smaller, or equal to V2? Bigger. Bigger voltage here than I have here. So what does that say about the charges? All right, just a few more seconds. I'll stop at 110 or 112, let's say. Okay, good. B is right. If I have 10 volts here and 5 volts here, then I'm going to have 10 microcoulombs, Q equals CV, and 5 microcoulombs here. Bigger voltage, identical capacitors will give me bigger charge. Oh, is that it, really? That's all that you have in your book, too? Okay. That's it. All right. Well, let's try this. This is more like what you would have on your exam. You can see one maybe a little more complicated than this. But first, oh, sorry, this isn't a multiple choice. We just want to find the equivalent capacitance of this circuit. I find that when I'm doing these, that it's easier to redraw them first. And so you'll want to start from the positive side of your battery, going in this direction, and then redraw it as you go along in a way that just looks a little more like the circuits that we deal with. So the way I do this, and you'll probably want to do this on the exam, and that'll help me too. If you get the answers wrong, I'll be able to look at your redrawn circuit and say, oh, I see what they did. They thought this was in series and it should have been in parallel. And so that'll help you get some extra, or not extra, some partial credit on that. So let's try redrawing this. I have my 12 volt battery. I come to my 6 microfarad. And then I come to a junction. And whenever I come to a junction, I know that that's the beginning of a parallel branch. So I'm going to go up, and I'll draw this junction. And in this case, I only have 2 branches. Give them a little space. I only have 2 branches because I only have 2 branches here. Now this could have broken into 3 branches. Like for example, if I had, say, another branch right here, then I would have drawn 3 branches here instead of 2, because you would see I would have 1 branch, 2 branches, 3 branches. But that's not what I have. Take that away. Oh, I can't. All right, so I have 2 branches, and then I just draw one of them. I have C2 right there. That's a 4 microfarad. And then down here I have C3. That is a 1 microfarad. And then I come along here and I say, well, gosh, I have another junction. Now you might say, why would I not draw this junction? We're not going to draw this junction, in fact. I'm not. Well, it'll be there, but I'm not, because I have now a clear path back to the battery. And so that's why it's important as you think about these circuits, you start on the positive side and you move in that direction, like we would think about if we were thinking about protons moving through this circuit. Finish drawing it, then I'll show you how that junction comes back. So now I'm up here. I have how many branches there? I have 2 extra branches. So now that branch is breaking into a branch. And then I have my 2 microfarad, my 2 microfarad, and then this comes back together right here, and then this all comes back together like this, and then I go back to my battery. So when I get the circuit that looks like that, it begins to make a little more sense than when I see it like this. But on circuit diagrams, you see it laid out on a grid like this, not in this way, which just tends to make a little more sense, where our parallel branches are clearly marked out. Now let's go back to here. You see I had here, which is at this point. It does come back and meet these 2 microfarad capacitors that are in parallel, but it's really that it goes straight back to the battery. Now once you get it like this, hopefully this becomes pretty easy to see how to do this, because they're all combinations that we've seen before. A 2 and a 2 in parallel is what? No, not 1, it's 4. Remember, after you get your resistors and your capacitors mixed up, for capacitors in parallel, that's the problem doing resistors, because you've all done resistors right in lab. Try to forget that for now. It'll be important next chapter. 2 and 2 in parallel is 4. Capacitors in parallel just add up. 4 and 4 in series is what? It's 2. 1 over a quarter plus a quarter, that's 1 over a half, which is 2. Then I have a 2 and a 1 in parallel, that's going to be what? 3. 2 plus 1 is 3. Don't worry, I'm going to write this down. I'm just stepping through. 2 plus 1 is 3. So this whole thing is 3 microfarads. 3 and 6 is what? 2, not 9. You don't add them in series. You do that reciprocal thing. Okay? So 3 and a 6 is 9. Let me write all that down. So the first thing that we do is we pick out our smallest parallel or series branch. That's going to be this. 2 plus 2 is equal to 4. 2 plus 2 equals 4. So we just doing, let's go ahead and redraw this. You'll find, especially as you're learning these, that if you redraw them, it'll help you to see the circuit better. I have 4, 4, 1, and then I combine the 4 and the 4. 1 over a quarter plus a quarter, that's 2. And then I'll go ahead and combine the 2 and the 1 and redraw our circuit as a 6 and a 3. And then redraw it just as a 2. This is at 12 volts. 12 volts. So our equivalent capacitance equals 2 microfarads. Now also on the test, and don't worry, we'll work some where you have to do this. Have at least, we'll have one that we'll work through that's similar to this, but let's work through this one too. Let's go ahead and find the voltage on every capacitor. Okay, the voltage on every capacitor. Now, there's the hard way to do it, and then there's the easy way. Let me step through the easy way. But the easy way requires that you know these relationships. What happens when the capacitor is big to the voltage? What happens when the capacitor is small to the voltage? By the way, if the capacitor is big, what's the voltage? Big or small? Small. Small, right? Because that Q equals CV. C goes up, V goes down. All right. Here, voltage on the 6 microfarad. What is it? It's 4 volts. Because big capacitor, small voltage, it's bigger by a factor of 2. So the voltage on it will be smaller by a factor of a half. But the voltage here and the voltage here have to add up equal to 12. So I'm going to have 4 volts, 8 volts, 12. We've seen that combination before, and you'll see it on the test this week, or next week. So I have 4 volts and 8 volts. Am I missing something here? Oh, yeah, no. So I have here 4 volts. And then across this whole thing, I have 8 volts. All right? So what is my voltage here? What do y'all think? Well, you gotta be in series first. I want to know the voltage. Look, I know I have 8 volts across this capacitor. So across this whole parallel branch, I also have 8 volts across that whole thing. All right? So now I want to know, this branch and this branch in a parallel circuit, what is the voltage across this part? I hear 4 and 8. What do y'all think? It is either 4 or 8 across that 1 microfarad. But nobody really seems very confident, because you're all sort of mumbling it. 4, 8, 4, 8. 8 volts. Okay? They're in parallel. Anytime you have capacitors in parallel, they have the same voltage as their source. Right? That's one of our rules. Capacitors in parallel have the same voltage. They also have the same voltage as their source. So we talked about this in terms of a battery before, but now you can imagine that this whole thing is hooked up to an 8-volt battery. So I have 8 volts across this branch and 8 volts across this branch. So what is the voltage across the 4 microfarad capacitor? 4 volts, right. Because 4 volts and 4 volts have to add up equal 8 volts. So when they're in series and they're identical like that, they're going to split that voltage. When they're in series and they're not identical, like we saw here, They split it, but they don't split it evenly. They don't have the same voltage necessarily, only when they're identical. All right, so let's step through that a little more difficultly. Is that a word? Difficultly? I think it is. With greater difficulty. All right, let me just sort of clean up a little bit just to remind you, these are capacitor measures. This was 1 microfarads. So, if you wanted to do this, like if you couldn't do that bit where we say, well, I can think about how the voltages are distributed, then you can do it the harder way, which is where here I say my charge is 24 microcoulombs. So that tells me I have 24 microcoulombs here and 24 microcoulombs here. Now once I get that, I can find the voltage because voltage equals Q divided by C. So Q divided by C here is 4 volts and 8 volts. But that's what we said already. The 6 microfarad capacitor carries a smaller voltage by a factor of 2, and so this has to be 4 plus 8, because those are the only numbers where one is half the other, and they still add up equal to 12. All right? So let me blow up this circuit over here. So now we know that we have 4 volts across this capacitor, and we have 8 volts across this whole thing right here. So that tells me that I also have 8 volts here, and it tells me that across these two, I also have 8 volts. Now, at this point, hopefully you can see, well, similar capacitors, identical capacitors have the same voltage. But if you're uncertain of that, then you could say, well, what is the equivalent capacitance of this? The equivalent capacitance of those two 4 microfarad capacitors, remember, was equal to 2 microfarads. And so the equivalent charge is going to be 2 times 8, C times V, or 16 microcoulombs. So I have 16 microcoulombs here and 16 microcoulombs here. And then if I want to know V, V is Q divided by C. That's going to be 4 volts and 4 volts. 16 divided by 4. Okay? It'll be much easier, however, if you just think about how the voltages are distributed as you go through this circuit. And that can be kind of tricky. Like you got to do it quite a few times to really get the hang of it. But the good news is you have a lot of practice. We'll have another practice in class here, and then you have one in the homework, and then practically every exam there's one that you can practice, and they're all slightly different. And the one that you'll have next Friday will be slightly different. But you will have a circuit similar to this, and you have to find the voltage and the charge on each capacitor, as well as the equivalent capacitor. Okay? So please be prepared to do that. It'll be 15-ish points, so it's not an insignificant chunk of your exam. But you'll definitely have one of those. Okie dokie? Y'all be able to do that? You will be able to do it. I just want to say something too, because I know that there are rumblings in the lab and stuff like that. I've heard it. There always are. But for some reason, like, women think that they can't do circuits. Not every woman. Like, a lot of y'all know that you can do circuits, and that's great. But for some reason, like, you've been told along the way that you can't do circuits, and it's really not true. Like, you can do circuits or you can't do circuits. With practice, you can, and you're not any better and you're not any worse than the guys in the class. But for some reason, the women have been told this. And I don't want you to think that's true, because it's absolutely not true. Okay? Just because you're a woman doesn't mean you can't do circuits. You understand what I'm saying? Y'all follow? Have you ever been told that you can't do circuits? Probably never even come up. But for some reason, that comes up sometimes, especially in the lab. So don't think that's not true at all. Okay? Anybody think you can't do circuits because you're a woman? All right, right answer. Good. All right. Let's try doing. Let's try this quicker question. What is the charge on the 3 microfarad capacitor? You can see something like this in the multiple choice. But it's good practice for the bigger circuits too. If you finish this one, go on and do the next two. folks, some of you are giving this a lot more thought than you really need to, because you should be able to look at this, especially by now, and tell me what is the charge on that 3 microfarad capacitor without even really putting your pencil to the paper that much. Okay? So remember the 3 and the 6 combined, those have what kind of voltage across them? What is the voltage across this branch right here? Is 12 volts. Similarly, you have 12 volts across here. And so you have 12 volts distributed across a 3 and a 6. Think about what is the voltage on each. And then once you know the voltage of the capacitance, the charge is just C times V. That voltage times that capacitance. Okay, good. That's better. But you want to be able to look at that in just maybe 10, 15 seconds know what the answer is. I'm going to stop at 2:15. That is right, B. Yeah, that's right. Okay, B is the right answer. So I know that not everybody's there, and you can't just look at this in 10 or 15 seconds and know the answer, but you want to move towards that goal because it'll help you on the exam to see the circuits a lot better in your mind. So I have 12 volts here. By the way, what's the charge on this capacitor? What is it? Not 12, but 24, right? Because I have 12 volts, 2 microfarads. C times V, 2 times 12 is 24. What is my voltage here? Small capacitor, big voltage, 8 volts, right? 4 volts here. So if I have 8 volts, 8 times 3 is 24. By the way, if I have 4 volts here, what is the charge? 24 microcoulombs. Remember our rules, capacitors in series have the same charge. So that works out there too. In fact, that's sort of the long way that you would go about getting that answer, is you would find the equivalent capacitance of these two, which is 2 microfarads. 2 times 12 is 24. Realize you have 24 and 24. 24 divided by 3 is 8. But that's sort of the long, harder way to get the answer. Let's try this one. What's the equivalent of this one? Just try looking at it, okay? Don't just try looking at it and thinking what the answer is. If you need to write down something, that's fine. But you have familiar combinations. They're doing pretty well. Those of you that answered in. We'll do about 15 more seconds. Stop at 55. 55. Just guess if you don't know. Okay, good. A is the right answer. 4 and 4. 2. 1 over a quarter plus a quarter is 2. 2 and 2 in parallel. 2 plus 2 is 4. So that gives me this whole thing is 4 microfarads. 4 microfarads. 1 over a quarter plus a quarter is 2. Sketch that out right quick. This is 1 over a quarter plus a quarter. That's equal to 2. Combining that with this gives me 2 plus 2. That's equal to 4. So I get a 4 and a 4. Combine those two, and I get 2 microfarads. So A is the right answer. What is the potential across the 2 microfarad capacitor? Is it 8, 4, 6, or 2? The potential across the 2 microfarad capacitor. Across this one. All right, I'll stop at 45, 45. Is that right? C6? Let's cross the 2. That's right. Good. Okay, so this circuit right here is equivalent. I have 4 microfarads, 4 microfarads, 12 volts. Because those are identical capacitors, I have 6 volts and 6 volts. They're in series, they're identical, so I have equal voltages. They both have to add up to equal 6 volts. So over here I have 6 volts. Across this whole thing, I have 6 volts. All right, that means I have 6 volts here. What is it across this 4 microfarad capacitor? 3 volts. Awesome. And 3 volts there. So you can look at a circuit like that, and likely, or not even likely, yes, on your exam, you should have nice even numbers on almost all the capacitors for the voltages. Okay? Don't freak out if you have 1 or 2 that don't have even numbers, but you should have even numbers on most for all the capacitors. Alrighty. Let's try this question that's like on the test. And again, you have some in the homework that are like it as well, and if you look back at old tests, you can find them. I want you to first just try to redraw the circuit. So remember, you're going to start here on the big side of the battery, redraw up to the first junction, which is right here. You have how many branches here? 2 branches, so you'll draw a parallel branch with 2 branches. The tricky part is what happens here. What happens here is those 2 branches close, and you open up another 2 branches. So you're going to have 2 branches in parallel, they'll close and move along, and then you'll open up to 2 more branches in parallel, and then those will close, go back to the battery. So first just try redrawing that circuit, and then before you move any further in a couple minutes, I'll redraw it for you just to make sure that we're on the same page. And then from there, you should be able to find the voltage and the charge on each capacitor. So go ahead and take 2 minutes, say, and redraw the circuit. At 8:10, I'll redraw it. If you're confident, you can move on. Now, if you have any questions about it, I can help you. I'm going to start redrawing it up here on the board. That's what I get. That's just redrawing the circuit. Now you want to find the equivalent capacitance of that circuit and try to find the voltage and the charge on each. If you find the voltage on all of them, then finding the charge is really easy. It's just the voltage times the capacitance. gotten pretty good with these, you might be able to look at this. Just tell me what the voltage is across all the capacitors. Anybody have an equivalent capacitance? Be raising your hand. No, 4.5. No, not 4.5. It's 1. So the equivalent capacitance is 1. Let me show you. 3 and 6. 2. 2 and 1. 3. 2 and 2, 1, right, 1 over a half plus a half, 1 plus 2 is 3, so that leaves me with a 3, a 3, and a 3. 1 over a third plus a third plus a third is 1. Right, so the equivalent is 1. Now we need to figure out the voltages on all the capacitors. And I'll give you another minute or two, and I'll show you. One more minute, and I'll show you the answer. All right. What's the voltage? 4 volts, right? Because look, I have a 3, 3, and a 3. They have to split up that voltages all evenly because they're identical. So I'm going to have 4, 4, and 4. I know it's 4 because this is 12. Because 4 plus 4 plus 4 is 12. So I have 4 volts here. You should be able to tell me right off what is the voltage here. That also has to be 4 volts. The reason is I have 4 volts on this capacitor, I have 4 volts on this whole parallel branch, and on this whole parallel branch. So that means that I get 4 volts across here and 4 volts across here. So this is just one capacitor, it has 4 volts. What is the voltage across this capacitor? 4 is right. So I have 4 volts here. Should be pretty easy for you to tell me now what is the voltage across this capacitor. I remember I had 4 volts across this whole thing, two identical capacitors. Two, and 2. So I have 2 volts here and here. These are a little more complicated, but we've done this one before. If I have 4 volts across a 3 and a 6, that's going to be 2 numbers that add up to equal to 4. One's going to be twice that of the other. Do y'all remember those? They were fractions. What were they?
The 3 was 8/3.
Yeah, the 3 has this bigger voltage. It's going to be 8/3 of a volt. And this is going to be 4/3 of a volt. But remember, if you're not sure about that, you can always imagine a circuit that is 3 and 6. It is connected up to a 4-volt potential, right? Because I have 4 volts across here. If I have 4 volts potential, my equivalent capacitance is 2 microfarads. So I have 4 times 2, 8 microcoulombs of charge on each of those. I just multiplied the voltage times the capacitance and got the charge on each. And then V is Q divided by C. So it's going to be 8 divided by 3, 8 divided by 6, or 8/3 and 4/3. So you might have to do the sort of work through the charges to get that if those fractions aren't immediately apparent to you. But notice that one is twice the other, and they add up to equal to 4, 8/3 and 4/3. All right? If you did pretty well on that one, so now we have all the answers. We have 4, C2 is this one, so that was 8/3, 4/3. Oh wait, no, I'm sorry. I got it mixed up. This is C3, which is this one, so that's 4 volts, 4/3. C5 is this one, that's 4 volts, and then C6 and 7 here and here are here and here, so that's 2 volts and 2 volts. And the equivalent was 1 microfarad. And then to find the charge on each, I just multiply the voltage times the capacitance. So here's C1, so that's 12 microcoulombs. C2 is 3 microfarads, so that's 24 divided by 3, or 8 microcoulombs. C3 is 1, so that's 4 microcoulombs. C4 is 6. 6 times 4 is 24, so that's 8 microcoulombs. Notice that it's the same charge as C2 because they're in series. C5 is 2, so that's 8 microcoulombs. I'm just multiplying 2 times 4. C6 is 2, so this is 4 microcoulombs. Multiplying 2 times 2. And then C7, well, it's in series, so it should have the same charge, and it does 4 microcoulombs. All right, just a little hint to you that even if you get these voltages wrong, you can still pick up a lot of credit. I won't give you exactly half credit, but you'll get, not close to it, but pretty close to it if you get all of these right with the numbers. So even if you have your voltages wrong, make sure that you're doing this properly, where you're just multiplying the capacitance times the voltage, because that will give you partial credit for that. And that's just C times C. All right? But even better is if you just get all the answers right, because that makes my life a lot easier. It's easier to grade. It's hard to grade if all the voltages are wrong. Okay? Y'all do that for me? Get all the answers right. I would love to just get a whole stack of papers one day, and every answer on every test is exactly right. Because, man, I'd be done in like 5 minutes. It's possible. I know it is. All right. One more thing. We've already watched this video. It's the one with Colin. The energy stored in capacitors. That's what capacitors do, is they store energy. That energy is equal to 1/2 CV squared. See, you can see it, like I might ask you, like on that previous question, how much energy is stored in such and such capacitor? You know the voltage, you know the capacitance, you can calculate the energy. So for example, the energy here is 1/2 of 10 microfarads times 2 volts squared That's 5 times 4. That's 20 microjoules. You won't see anything terribly complicated. It'll just be sort of poked in a problem maybe on a circuit I give you, and I ask you what is the volt or what is the energy stored in one of these capacitors. The equations are on your equation sheet, so don't even bother memorizing the equation. Just sort of know that it's there, worth maybe a point or something. Let's try this little clicker question. We'll wrap this chapter up. We'll see energy again in chapter 4 on capacitors. It changes. Watch your units, okay? I give them in SI units, which is joules, not microjoules. You hear what I said? The units and the answers are in joules, not microjoules. So be careful with that. All right, I'll stop in 1 minute, at 1 minute rather. All right, good. He is right. Let's see, if I told y'all, why does the gingerbread not go to the beach? Have I told y'all that one? I mean, why does the gingerbread not go to the beach? He's got crummy legs. All right, so A is the right answer. 1/2 CV squared, 1/2 of 3 times 10 squared. That's 150 microjoules, but that's 150 times 10 to the minus 6 joules, which is this. If you give the answer in microjoules, that'll be fine. It won't be a multiple choice for that. Okay, so just a quick note. We're done with chapter 2. We are going to move on to chapter 3 on Monday. Oh, seriously? Really? Gosh, you're such a jerk. I hate you. Go and get it out, okay? All right, we are going to move on to chapter 3, but chapter 3 will not be on the exam because chapter 3 really holds together with chapter 4. It's on current, resistance, and Ohm's law, and that's really what we're going to be doing in chapter 4 is Ohm's law stuff. So we're going to sort of keep chapter 3 with chapter 4, and we already got a whole load of material for this next exam. So chapter 2 is a big, big chapter, and then we also have the Gauss's log that we'll see on the next exam. So we'll just keep it at that. That will be your exam, that chapter, I'm getting them all confused. We had chapter 0.5 and chapter 2. That's all right on the exam. But chapter 2 is a big old chapter. So you need to know capacitor circuits, you need to know your electric fields, your partial derivative business, you need to know voltages, all that stuff. So anyway, just heads up, we are going to continue on with chapter 3, and we'll probably even finish chapter 3 on Wednesday. But we will have review, and you will have to do that derivation on Wednesday. We'll do it at the beginning of the class. I'll give you 15 minutes to do it, or maybe, yeah, 15, that should be plenty, right? 15 minutes? And then we'll review, and then if y'all run out of questions, then we'll carry on with chapter 3 on Wednesday. But not going to let you out early, okay? Even though it's the day before test. You have a great day, okay?